All right, good evening. So welcome back to College Algebra. We're going to do some examples involving the vertex formula here. Right. So almost any of these are things that I would rather not try to do complete the square on, all right? Because they're going to be kind of painful. All right, so all they want to know is like, let's figure out the vertex, all right? That's a formula you need to practice with, and here we go. So we have f of x, right, is equal to 4x squared minus 24x plus 119, okay? I'm sure that looks delightful. So they said find the vertex. So remember, right, x is equal to negative b over 2a. That's the x coordinate for the vertex. Vertex is found at x equals negative b over 2a. So we have negative, that's this negative, right? And then we have the b. So the b is negative 24 because that's our, this right here, that's our b, divided by, I really wish I could do this faster. Okay, divided by 2, and then what's our a? A is 4. All right, here's 4. All right, that's where that's coming from. So negative and negative, that's going to be a positive 24, right? Divided by 2 times 4, that's going to be 8. All right, and we end up with x equals 3. Okay, so x equals 3 is the x part of that vertex. Now we got to plug it in. So we have, what is f of 3, right? This is that b over 2a stuff, see? When it's 3, it's not nearly as scary, all right? So this is equal to 4 times 3 squared minus 24 times 3 plus 119, all right? 3 squared, I think that's 9. 4 times 9 is 36. Minus 24 times 3, what is that going to be? 72 plus 119. Okay, 36 minus 72 is negative 36 plus 119, and unfortunately I'm going to have to do this. So negative 36 plus 119 is 83. So let's see here, we have vertex is 383. All right, let's check. Okay, 383. And that's all they want us to do in this case. All right. The middle of the section, they just, you know, it's a nice relief from the first ones where they had to ask us, you know, part 27, and now it's just one and done. All right. So let's see, we have 4, 5. Okay, here, actually, I think I did give this to a student, to a class one time to do complete the square on. It didn't end well, but here we go with applying the vertex formula. All right, so we have k of v is equal to negative 1/3 v squared plus 8v plus 6, right? And again, find the vertex. Vertex is x equals negative b over 2a. Here's b, here's 2a. So you have to be a little careful in this case, right? So this is going to be negative 8 divided by 2 times a third. It's negative. So there's 2 negatives here, they're going to cancel. So we have 8 over 2/3. All right. Now this might be a bit of a problem, right? Really what we have here is 8 divided by 2/3. And if you remember your rules for fractions, right, we multiply by 3/2. 4 times 3 is 12. All right. The other way to do this is to realize that the 8 over 2/3, right? This one is the heavy line. Okay, that one's the real fraction part. This 2/3, that's nice, but we could replace this as an 8 over 1 over 2 over 3. Right? And what we're going to do here is we are going to multiply by 3/2. Right? That's all going to cancel out, and that is equal to 24 over 2, which is 12. Okay, and then there's one other way to do this. Okay, and that's again 8 We know that that's the heavy 2/3. So what we're going to do is we're going to call this 8 over 1 over 2 over 3. And what we're going to do is we're going to multiply by 3, top and bottom, 3 over 3. And it's equal to 24 over 2, which is 12. So this way is like, there's a really fast way. This is like the math teacher favorite way. But this is, I don't like to use this because most students learn this way or are more comfortable with this way. Okay. So I would prefer to do one of these because students tend to be easier, it's easier for students to follow this one. This one, I guarantee you, calculus teacher will pull this thing out every once in a while just to do it. But it's a thing. So it's true, it works, it's real. We're just multiplying by top and bottom common denominator, right? 3 times 1 is the common denominator here, so 3 over 3. 3 times 1 over 3 times 1, and that takes care of all of that. But like I said, use whichever one of these makes the most sense to you and you are happiest using, because they are all equivalent and it's just there. So we know that x is 12 after all of that. Okay. So going back up to this, we have b is equal to negative 1/3, or k rather. Okay, we get 12 squared here plus 8 times 12 plus 6, right? And then we have to figure that out. So remember, exponents happen before multiplications. It's negative 1/3 times 144, okay, plus 8 times 12 plus 6. I like to do like one thing per line, so that's how this works. Let's see, 144 over 3, 144 over 3, so that's going to give me 40, so that's going to be 12. Oh, wait, no, is that right? Yeah, that's 24, 3 times 48, there we go. Negative 48 plus 96 plus 6. Okay, negative 48 and 96. What is that going to be? That's going to be 46, 48 rather, plus 6, and then we have 54. Okay, so our vertex should be 12, 54. Hopefully I didn't lose a sign in there, but 12, 54. Always. And this one too, they just wanted the vertex and then you're done. They let you go. The only reason I put this one on is because the b term wasn't there. So we have 4b squared plus 6. Find the vertex. Vertex is v is equal to negative b over 2a. Well, what's the b? What's the middle term? In this case, 0. 2 times 4. But 0 over anything like that, 0 over 8 is 0. Be careful, right? If I multiply both sides by 8, you get 0 is equal to 0 times 8, and I'm pretty okay with that. But if you ever come into a situation where you're like, well, 8 over 0 is equal to 0, like, really? Multiply it back out. So 8 is equal to 0 times 0. You like that? No, I didn't think so. So this one is undefined. Okay. We also have 0 over 0. You say, what do you want this to be? I'm like, oh, I want it to be 1. I'm like, okay, well, in this case, since we have a 0, could I replace this with any other number? Yep, I could have said 2. I could have said it was 10. I could have said it was pi. Doesn't matter. Because once I put this back over here, anything I get, anything I want, we can just make this up. So choose, but choose anything you like, because it's always going to be, this is called indeterminate. Okay, nobody is going to hold you responsible. If you say it's undefined because it's over a 0, nobody is going to come back and say, oh, I don't think so. It's indeterminate. I mean, when you get to Calc 2, they'll correct you and say, no, this is an indeterminate form, and this is undefined. But until you get to that spot, you just go, it's all undefined, it's fine. Okay, the vertex, right, is 0. And if I plug 0 in here, we get, 4 times 0 squared plus 6, we get 6. Right? So in this case, the vertex that's what you do. B is missing. You set it to be 0. And then plug in 0 and we get 6 in this case. And then number 7 is the kind of problem that's going to make you really happy that you're using the vertex formula rather than complete the square. All right. This one's actually pretty tame, right? Because we got 0.5s. They're not always, right? Sometimes they were a lot worse. So we have 0.5x squared minus 3.5x plus 3.2. Find the vertex. Vertex is x equals negative b over 2a, right? So what's negative, right? There's a negative. Then my b is negative 3.5 divided by 2. And then we have a, 0.5. Okay. Again, this is this place where everybody makes a mistake, is because they get so excited. They get, okay, I got this, I kept that sign, I got the 3.5 divided by 2, I didn't forget anything, I'm good. Like, what about your A? Because I'll ask that, meaning it in, in both contexts, right? What's your A? And then you forgot this, so where's your grade of an A? You left it on the floor. All right, that's 3.5, and then 2 times a half. What is 2 times a half? It's 1. So my answer is going to be 3.5 here. All right. So we have to plug this in. Right? So we have 0.5 times 3.5. I'm going to use the calculator on this one. There is no way. I'm going to try to 3.2 here. Okay. So there we go. Calculator is for this one. Oops, I don't want that. I want a calculator. So we have 0.5 times 3.5 squared, all right, minus 3.5. I could say 3.5 squared, couldn't I? Because there's 2 of them. But I'll just say 3.5 times 3.5 plus 3.2. The oracle says negative 2.925. Just in case you have a teacher in the future that will insist that you always use fractions, you can come over here to this math button and you see this where it says turned into a frac. It'll just take your answer and turn it into a fraction. So we could also say this is negative 117 over 40. I'm sure that'll be impressive. But in this case, since they handed you fractions, I think that you should hand them fractions back. If you ever have to deal with teachers like, I thought, we said you were going to use fractions, right? Okay, sure. Let me go through and do it regular, and then I'll just convert it and tell you what you want to hear at the end. Here, all right, we're good. Let's see here. So, and I'm guilty of that, by the way. I will tell students like, hey, you should use fractions, especially if the problem comes out with fractions. You should be done in fractions. But I fully know about this button, and it's just more of a, somebody asks you a question in French, you answer in French. What is this? Not negative 2.925. But since we have Google Translate, you can, you can check. All right, we're good. These were kind of short. Let's go to number 9 and see about that one. It's a little bit more involved. See, this one is, wow, there's a lot going on here, all right? So the ones after this are word problems, so we'll go ahead and finish this one up, and then the next video will be all the word problems for us. All right, because I'm hyped. So let's see what we got here. Here's our function. F of x is equal to 3x squared plus 9x, and what do we have here? We have minus 2. Here's another one we have, a gazillion parts here. To state whether the graph opens up or down. Up, down. Well, what's my coefficient? Is it positive or negative? 3 is positive. We open up. All right. Identify the vertex. Now, this is completely up to you as to how you would like to solve it. I personally would try to avoid anytime I would have to do complete the square when the first coefficient isn't 1. So I'm going to go ahead and say x is equal to negative b over 2a. All right. But if you are really into the vertex form, feel free. Right? So this is negative 9 over, right, the negative here, negative 9, 2 times 3. All right, so that's negative 9, 2 times 3 is 6. Okay, cast out of 3, we get negative, I think 3 halves there. Okay, so x is negative 3 halves. Now we have to go through and plug this into the function, right? So f of negative 3 halves. Okay, that's a little scarier. Still, like, not quite, b over 2a, but it's awful. Is equal to 3 times negative 3 halves squared. It's going to be positive. Plus 9 times negative 3 halves minus 2. Okay. So 3 halves squared, that's going to be 9 quarters, right? 3 squared, 2 squared. This is times 9. This is going to be minus 27 halves, okay, minus 2. So we have 27 fourths minus 27 halves minus 2. I'm going to go ahead and multiply 2 over 2 here. So we have 27 fourths. Let's say twice 27 should be 54 fourths. And then minus 2, which I'm going to call 8 fourths. Okay. So we have 27 minus 54 is negative 27. 27 minus 8 is going to be negative 35 fourths. Okay, so my vertex is going to be negative 3 halves. And I'm sure I encourage you, type this in your calculator, get an answer, press your fraction button, and see what you get. All right. So you're quite allowed to do that. Y-intercept. Okay, well, again, we didn't do X-intercepts yet. Oh, this is going to be hard. Okay, X-intercept. All right, can we factor this? Let's see, if I take the first number and the last number and multiply them together, we get negative 6. Can you think of two numbers that multiply out to negative 6 but add up to 9? I can't. So if only there was some kind of a formula we could use to solve quadratics. Oh, no. Oh, wait. Yes, I do. This one. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Let me get rid of that. There we go. All right. This is always the fun part, right? So we have negative 9 plus or minus the square root of 9 squared minus 4 times a, 3 times c, negative 2, all over 2 times 3. All right, so we have negative 9 plus or minus, and then we have 81. Negative times negative is positive. And it looks like we've got 4 times 6, so plus 24. All over 6. What is this going to give us? This is going to give us 105. One of 5 is 5 times 21, which is 5 times 3 times 7. There's nothing there. Okay, we're just hanging out with this horrible number. Okay, so my x-intercepts are x is equal to negative 9 plus, 9 plus square root of 105 divided by 6, and x equals negative 9 minus the square root of 105, all divided by 6. Like I said, I'm sure those are delightful numbers. Yeah, we'll come back to that. All right, those are my x-intercepts though. Okay, we put a 0 here, we put a 0 here, and there's 0 points. Okay, y-intercept. Well, that's a lot easier, right? We have f of x is equal to 3x squared. What is that? Plus 9. Plus 9x minus 2. Well, when I plug in x equals 0, we get 0 plus 0 minus 2, negative 2. So 0, negative 2 is my other point here. Okay. Oops. Sketch the function. We're going to do that in a minute. And then it asks us the same extra questions that we already know the answers to because we know where the vertex is. Okay, this graph opens upwards. All right, fantastic. Identify the vertex. What did we say the vertex was? The vertex was negative 3/2, negative 35/4. Negative 3/2, negative 35/4. Crossing my fingers, hoping that I didn't make a arithmetic mistake. Look at that. All right. The X-Intercepts, notice they give us all the tools we need. Who would have thought? All right. So what do we have here? We have negative 9 plus root 105 all over 6. So let's give it a fraction. And we'll say negative 9 plus square root 105 all over 6. What was y? 0. Okay, and then we have to do a comma because there's more than one answer. All right, and we have, again, make a fraction. All right, we're going to have negative 9 minus square root 105. Make sure the negative is on the outside of the square root, otherwise you're going to end up with imaginary numbers, and you really don't want that. Okay, 0. Okay, double check me, make sure we're good. Negative 9 plus root, negative 9 minus root. Okay, looks like we're okay. Let's check. Hold my fingers there. All right. Y-intercept. Finally, something that's easy. 0, negative 2. Watch me screw this one up. Check it. Looks good. Now we got a graph. All right. Remember when we talked a little bit about graphing before, and we said, well, first off, we said there's ways of using the shift or the control button to change your zoom. But I'm going to go ahead and plot a whole bunch of points here because I'm not going to be good about figuring out where things are. We had our vertex, right? Where's our vertex? That's a point we need. Negative 3/2, negative 35/4. So negative 3/2, negative 35/4. All right, so let's plot that point. Notice that I do not have a radical. Okay, we will not be able to plot points that are going to be on the axis. Usually they only want one extra point. So why don't we go with 0 and negative 2, right, as my y-intercept and hope for the best. All right. Notice they say don't put a decimal in here. So don't approximate your intercepts and say, well, if it's approximately, they will not like it. It'll be wrong because the radical, right, is different. All right, placing the vertex, done. Curve opens up. Okay, find one other point. Let's pick that one and we'll check. All right, so we're good. All right, and we'll go back down. All right, see. All right, axis of symmetry. Where is the x part of the thing? Right, that was x equals negative 3/2. Oops. There. Set. The function has, right, a minimum value, right, smallest. There is no maximum because it keeps going up, and away. So the function has a minimum value. We'll check that. Of course it does. The minimum value is negative 35/4. Oops, I wanted negative 35/4. All right, we're okay there. The domain, right, nice question. It's a polynomial, so the domain is all real numbers, and the range, we have a minimum, right, and that was negative 35/4, and on forever. right, and there's all those little points, all those little spots. Okay, so I'm going to go ahead and leave us with that, and we'll do some word problems in just a moment. So let's go ahead and stop, and we'll be back in a minute.